Okay, in this video we're going to derive the angle sum identities for trigonometric functions. So I've listed the four identities over here. So let's dive straight into it. So the easy way to derive these identities is to just use rotation matrices and vector algebra basically. So the way to derive these identities is to do the following. Let us say you have the x and y coordinate system, and then let us say we have a vector v which has an angle alpha. Then what we can do is we can rotate this vector v by the rotation matrix. So we get the rotation matrix as a function of beta times v, and we rotate it by an angle beta, right? So what we then get is a vector with the angle alpha plus beta, right? So that's what we're going to do. So the only thing that you need to remember is the following. So the vector v has the coordinates cosine alpha and sine alpha. This is the unit vector, and that's quite straightforward to understand, right? Because if the length from here to here of this vector is 1, then this guy here is cosine alpha. That's the x coordinate, and the y coordinate is just sine alpha, right? And then what you need to remember is the rotation matrix. So the rotation matrix in the anti-clockwise direction is just cosine beta minus sine beta sine beta times cosine beta. So that's also quite easy to remember, right? So on diagonals you have the cosine betas, and then you have to remember that you have all the off diagonals you have minus sine beta and beta, sine beta, right? So now we're going to apply the rotation matrix R to the vector v, right? And if we matrix multiply this, then let's write it out. So we have cosine beta minus sine beta cosine beta, and all of that times cosine alpha and sine alpha, right? So that's going to be just, if you do the matrix multiplication, cosine alpha times cosine beta, right, this times this, and then minus sine alpha times sine beta, right? That's the first one. Then the second one is just cosine alpha times sine beta times plus sine alpha times cosine beta, right? Now this is a new vector rv, and now we already know the coordinates of the new vector rv because it's just the same vector, the unit vector, but now at an angle alpha plus beta. So this is equals to cosine alpha plus beta and sine alpha plus beta, right? And now we can very simply straightforwardly read it off. So cosine alpha plus beta is just this one. Let's highlight this. So let's make this green. Is this, and sine alpha plus beta is just this, right? That's it. That's how you can remember the addition theorems very easily. Let's write it out just for completeness sake. So we have cosine alpha plus beta is cosine alpha cosine beta minus sine alpha times sine beta. And if I now want to know cosine alpha minus beta, then all I have to do is I can take this identity and substitute beta with minus beta. So this is cosine alpha times cosine of minus beta, but cosine is an even function, so that's the same as cosine of beta minus sine of alpha. And now sine of minus beta is minus sine of beta, so this becomes a plus and we get sine beta, right? We can do the same thing with the sine identity. So the sine identity a plus beta, we read it off from here, is cosine alpha times sine of beta plus sine of alpha times cosine beta. And now similarly to before, to find out the angle difference, we just substitute beta with minus beta. So we get minus cosine alpha sine of beta plus sine of alpha cosine beta. That's it. If you compare this, these are exactly these two identities over here, right? So there you go. That's the way how you can very easily remember. Just to recap, we need to remember the following. Basically, most of the stuff can be derived from first principles. Basically, you already know that when you have a vector v, a unit vector which is at an angle alpha, the coordinates of this vector is just cosine alpha and sine alpha, right? Because of the trigonometric definition of cosine and sine alpha, the only thing you need to remember is the rotation matrix. It's basically the cosine beta is always on the diagonal, and then we have minus sine beta and sine beta. It's very important that you remember that the minus sign is in the upper right corner if for an anti-clockwise rotation. You could of course do a clockwise rotation, but then you will get the difference identities, right? And it's best always to look at anti-clockwise directions in this case, right? So we've got now, right, and then you just do the matrix multiplication, and the new vector is just cosine alpha plus beta and sine alpha plus beta, and this is because we've simply taken the unit vector and rotated it by an amount beta, so the total angle is now alpha plus beta, right? That's just what straightforward logic tells us. That's yeah. So, and then we equate these two equations, and then we have the two identities, right? So yeah, that's it. Okay, thank you for watching. Please subscribe if you're interested in more content like this. Give the video a like, and I'll see you in the next video. Bye.